This is Algebra 1, Term 3, Lesson 1, Inequalities, specifically one variable inequalities, and we'll be graphing those on number lines. Let's start with the Desmos activity. So this activity revisits linear inequalities on a number line. There's no solving really. It's just making sure that kids have a strong conceptual understanding of the notation and the graphs for inequalities. There are 16 different screens, but don't worry, this goes very quickly. Students are going to drag these blue points to fit a certain scenario, in this case less than 3. They're going to do it again, and they're going to do it again. And that's going to be put together with their classmates. They're going to describe what's happening, and then they're going to do this again. This time be careful, there are 3 points here, so you got to be sure to move them all. And then they're going to answer some questions, relate what's happening. And so notice all these points. What will happen is the students are adding points to their graphs. They're put together in your activity so that all the points will show up and look something like this. And then you'll generalize what's happening by writing an inequality to represent the graph. And here's another one. And then you'll look at some of these examples. These are number lines that were created by students and their guesses. And then you're going to choose the words and the expressions, the inequality expressions, to represent what you're seeing there. Now, putting these points together, we will create a more formal representation of the solution set for this inequality, and then we'll have a number line graph like this. Now, we have seen this before when we were doing domain and range and piecewise equations. So the purpose of this task is to reinforce this notation to represent open and closed, included and not included points. When we were doing piecewise functions, we were dealing with this, so this is just kind of a refresher, if you will. So here we have all these different ways to write with variables x and number lines, and so again, we're just practicing. Now this is a good place to have a conversation with your classes. Each one of these have their own unique characteristics, so you could technically pick any of them and then discuss what makes them different. So be sure to read the teacher moves and the sample responses, but my guess is that you will spend very little time on this part of your assignment. The directions up here say from 30 to 45 minutes, but I would say 30 minutes would probably be generous for an Algebra 1 class. The next task will be to graph inequalities in GeoGebra. These also very, very basic, but again, they're just getting refreshed here on the basic concepts of inequalities. So when they go to GeoGebra, they're going to see an inequality, and then they're going to create a number line graph to fit. So here it has open and closed. This one would be closed. Notice it's less than or equal, so that means this should go this way. And then it should be less than or equal to -5, so this should be over here. Now, as soon as it's correct, it will display that, and they will take a screenshot and put that on their slide. Now, there are 5 of these. I'm hoping every kid gets at least one that's backward like this, because that's a real common misconception that a lot of kids think the graph will be shaded to the left of 7, but as we know, that is not the case. Let's go ahead and show that. So this would be open, but the shading is reversed because the variable's on the opposite side. So you may talk about that. This is correct, but typically we write our variable on the left side, which would create a graph that kind of matches the symbol. That's all we're doing with the GeoGebra task. So there's 5 of these. It should go pretty quickly. And these tasks at the end of your slides is where you should spend the majority of your class period. I do have this lesson scheduled for 1 day, so expect to spend about half of your day working in these last few slides and then in the graspable math activity at the end. So let's take a look at this slide. Notice it's not asking the students to solve this inequality, but to talk about it. What does it mean to isolate a variable? Which operations are being used in this inequality? And what inverse operations would be used to solve this inequality? So now they're going to actually solve the inequality now that they've talked about it. They'll click on math.new, they will type the inequality in, and they will solve the inequality. They will also insert text boxes to label the process with the inverse operations that are being used, and then they will put a screenshot here. So now let's describe a solution process. The inverse operations used to solve this problem would be adding, subtracting, dividing. But notice there is no distributive property being used here. This is something I introduce early and review often with students because later on, in fact, not that long from now, they'll be solving equations, particularly quadratic equations, where distributing is not an option. So on the left side is the one from the previous screen, same one, but on the right side the distributive property was used. So I'm having them analyze these two processes and talk about what is different. Were the same inverse operations used? What changed? How many steps did it take to solve without using the distributive property? And how many steps did it take to solve using the distributive property? So they're comparing the two strategies. It's not that one's preferred over the other. At this point, it doesn't really matter. But it is important that kids be able to recognize there are different ways to do these problems, and they should not always be doing them a single way because they need to be flexible in their thinking. So on this problem, they are being asked to solve this inequality twice. They're going to use both the distributive property, and they're also going to use inverse operations without using the distributive property. So you might want to point that out if they're not understanding what's so different about that last slide. So for this problem, they will type this in. Greater than or equal will give the symbol and then the 11, and then click the check mark, and then they will work this out. Now one thing I want to show you is that we could add first and then divide and then subtract. Okay, but what happens when you do these problems? They often add in lots of steps. So I instruct the kids to give me one line per operation. So for the first problem, the first thing we do is add 3. We don't really need 1, 2, 3 lines to do that. So what you do is you grab this dot and you pull up, and now I've added 3 and got 14. That's all I need. Now I'm going to divide by -2, and that gives me this, and then I'm going to subtract 5, and that gives me this. So I've done 3 operations. We're going to put this on the screen on our slide. Now I'm going to arrange this by clicking here and moving this over. And click on transform to move it back, go back to the way it was. Now I could use a text box here to insert text, but I've just learned the hard way that those text boxes are very limited, and the slides text box is much easier for kids to work with. So I'm not going to label anything in here. I'm going to go ahead and put this on the slide, and then we can go back and label it afterwards. Now we're supposed to work this 2 different ways. So one way to do that is to click on this little gray dot to the right of the equation and pull it way over here, and it will copy it. Now if you want to move it, let's say it's too close, too far, or not lined up properly, click on arrange and then transform, and then you're going to work it again. Now we did not distribute last time, so this time to do it differently we're going to distribute. Unfortunately with a negative they make you do that twice. You cannot distribute -2, you have to do 2 and then the negative. So we're just going to go ahead and pull this up because I don't need to show both of those. So we distributed, now we'll click here to combine, and then we're going to add and clean that up, and then we'll divide. Alright, so let's see what we can get rid of. This is good. This is good. I don't need this. Let's go ahead and move this up. to cover that up. And I don't think I'm going to need that either, but wait a minute, I'm missing something here. Let's pull this down. See, I'm pulling down and getting a lot of steps in here. This is the step I want. If I were to add the 13 to the 11, I want to see a 24 here. So I want to see that one. And then I need to divide, but I don't need to show all these. I can go ahead and do the divide like that. So let's see if we got it all. We distributed -2 and got this. We combined these two numbers and got this. We added 13 to get this. We divided by -2 to get this. And that's all I need. I don't need any more. So let's go ahead and leave this alone, and we're going to screen capture this and put it onto our slide. Okay, so now I've placed it on the slide, and here's where they're going to insert text box to label their inverse operations. Now you may notice all of the steps in the first one were inverse operations. So let's click on text box, and let's add a text box, and let's type inside of the text box what we did. So this first one, we added 3, and then we divided by -2, and then we subtracted 5. So this is my 3. Now you can bold these, you can do all kinds. That's why we do it here, because we can make it whatever we want. I want to add some color to this. Let's think purple's good. And then I'm going to put some space in here, so I've got some options. So we added 3, we divided by -2, and then we subtracted 5. Those are our steps. Now I'm going to go ahead and use the same text box. I'm going to copy and paste it over to the other one, and you'll notice we did a couple of things here that were not inverse operations. For example, the first thing we did was distribute -2. That is not an inverse operation. So here's a good point to stop and talk about that. Distributive property is a process of simplifying an expression. It's not an inverse operation. And when we add the -10 to the -3 to get the -13, that is not an inverse operation. We're just simplifying the expression. So really the first 2 steps of this problem were simplifying the left side of the equation. We were not solving at that point. So really the only inverse operations were adding the 13 and dividing by -2. That's the only 2. So we really only did 2 inverse operations in this case. So I'm going to move this over here like that. All right, so the question down here is, what are different first steps and why are they both reasonable? Well, the first step on the first example here, I used addition first to isolate the -2 times the x plus 5. And then I used division to isolate the x plus 5, and then I used subtraction to isolate the x. So we're isolating this piece by piece using inverse operations. The first step on the other inequality is distributive property. And let me tell you, your kids will go to that property almost immediately. They will do it. And so it takes a lot of effort to kind of change their mindset that using that strategy every single time is not always your best option. In fact, you can't even use that option when you get to your quadratic equations later in the course. So we are trying to get them to be more flexible and not stuck on one strategy, and that is the purpose of this assignment. Let's take a look at slide 12. In this problem, they're going to divide by the -3 first, which is something really different, something they would not normally do. But I'm trying to get them to be flexible and to realize we're stuck on certain strategies because that's the only way we've seen it done. So what my goal here is to get them to see many strategies, different strategies, and be flexible in their thinking. So in this case, if you were to drag that 3 up under that 18, it will divide all the parts by 3. And that's what's so cool about graspable math. It allows them to truly experiment without messing up, without destroying the problem. So I'm going to let you play with this one. In the teacher notes and in the teacher guide, I will provide some additional assistance, and I will have screen captures of or screenshots of all the work for these, so you'll be able to see what it's supposed to look like, or at least what it might look like, because they could go a different route with some of this. But the question at the bottom is very important. Why is dividing not always a reasonable first step? Now, in this case, we can divide by 3 first, and it doesn't really wreck the problem. Theoretically, you could divide by 3 first on 100% of the equations out there, but does that make any sense? Is it a good idea, and why or why not? So that's a good conversation to have. Just because you can do it mathematically, does it get you any closer to a solution is the question. In this case, it does, and in some cases, it doesn't. Like, could I divide by 3 on this one first? Of course, I could do that. It would make a disaster of the problem, but it could be done. Now, here's one where there are multiple strategies. I'm asking them to come up with as many as possible. So let's see what they can come up with. There's at least 3 we've done so far. They could do all 3 of those methods on this particular problem. See if they can come up with something else. I don't know. And then finally, they're going to be creative. On the last slide, come up with your own inequality. Solve it. Make sure your inequality contains parentheses, because all these did. Make sure your inequality has multiple operations: addition, subtraction, multiplication, division. Solve it using at least 2 different strategies. It just says 2. And compare your 2 strategies with text. Insert a screenshot. Which strategy is more simple? Which is more efficient? Which takes the most steps? What are the inverse operations being used? And so forth. So this is our last task for our lesson today, and this is a graspable math activity. They are practicing solving using some goal state problems. So you're given an inequality and you're given a goal. Now down here in the bottom left corner are the number of steps, and I would talk to your students about the number of steps. If they are taking 10 or 20 steps to do a problem, they don't know how to do it. They are simply playing until they get it. And that's actually okay when they're first introduced to a topic or a concept. But at this point, they should know enough about inverse operations to know what they could start with here. And then have kids do it both ways. Compare their 2 strategies. At your teacher dashboard on these problems, you can pull up kids' work. You may ask the kids permission first, but if a student decides to multiply by the 3 first and another student decides to add 3 first, it would be good to show both of those and see, or you could actually do it on a separate canvas and put those up and show what they did and have the kids compare. So these are all the ones. Now we have ones with parentheses. Here we have one with a fraction. And then it gets more and more fun. We got a fraction. Let's see what they can do. Without you telling them, let's see what they can do. You'd be surprised. Before you do anything at all for them, let's let them play with it. And if a student gets it and the others aren't, maybe have that student show the class. That would be nice. All right, now the hotspot questions, they have an inequality solved, and they're looking for mistakes. So they're going to drag this dot over to this image if there's a mistake. If there's not a mistake, they're going to put this on top of the words no mistake. They do have a canvas down here to work with, and then they're going to answer the question down here. They will not be able to check it till they answer this question. Where inverse operations were used to solve this inequality. Something I have not mentioned is reversing the order, so that does come into play here. A good conversation to have. Now this one has a lot of questions. So describe the mistakes, if there were any, what inverse operations were used, and is there a more efficient method? Like, is there a different way to do this? They distributed, obviously. Could they have not distributed? Is there a quicker way to get to that final solution? So I've given them one to play with here. I encourage you to encourage them to try this another way and then talk about it as a class. So that concludes our inequalities lesson. Next time we will look at inequalities with 2 variables. Y'all have a great day.